Hi, I don't know what team we are, but today we're going to present the PIA of calculus. Well, it consists in an optimization problem that has six parts to be solved. The team members are Pedro Mogollón, Diego Almanza, Leonardo Méndez, Damián Muñiz, Ángel Fernando, and Cristian Daniel. Well, the problem is you have been called by M&M's to make a new presentation for their product. So you think in a cylinder that has a form of an M&M. They approve your suggestion, but they add one more thing. The can needs to have the capacity of 300 cubic centimeters while using the least amount of materials.
Part 1. Identify what you have to optimize. You have been asked to use the least amount of material, which is equal to the surface while maintaining an area of 300 cubic centimeters.
Identify what you have. The velocity is 300 centimeters to the cubic. Then to identify the velocity is pi times radius to the square times the height. And for the area is 2 times pi times radius to the square plus 2 times pi times radius to the times height. And that's all.
Well, the part 3 of the problem is to combine the equation and eliminate one of the two variables, as you can see in this procedure.
So the part fourth of this optimization problem is to find the local minimum. Well, the first part you need to do is recall that the derivative of that function needs to be equal to zero. So you found the derivative and it gives you this, and then you match both sides to, well, this is equal to zero, this needs to be equal to zero, and then you need to eliminate the denominators for it to be easier, sort of. And here we eliminate the denominators, and this 0 is equal to 4 pi r to the cube minus 600, and then you need to isolate the r, that in this case is 600 over 4 pi is equal to r to the cube, and the root of this is equal to r. And then the other part of the local minimum is found in part 5.
In order to get the result, I just had to clean the radius and then check that it is the local minimum.
Okay, now part 6. I'm going to be alternating the camera from to back so you can see the presentation. Part 6 starts with the substitute of h, so the result will be 7.2558, as you can see here in the presentation, and therefore the value that can use the least amount of materials is when r equals the 3.6278 and the h equals the already mentioned 7.2558, as you can see in the presentation. Here it is.